Hello, and welcome to Nexstara's video series on the Salesforce Developer Workbooks. In this track, we'll be walking you through the Apex Workbook. This video covers Chapter 2, Tutorial 8, sObjects and the database. Apex is very tightly integrated with the Force.com database backend. In this tutorial, we'll learn how to work with sObjects to create, persist, and update database objects, as well as query the database and iterate over the results. To begin, we're going to want to go ahead and log into our Salesforce Developer Sandbox. And from the sandbox, click on your name and open the Developer Console. Now that we're in the Developer Console, go ahead to Debug, Open Execute Anonymous window. Now I'm going to start with a few generic examples of sObjects. To put it simply, an sObject is an Apex object that is directly tied into the Force.com database. They allow us to reference the Force.com database in a very direct and streamlined way. The sObject type in Apex is an abstract type that can be used and associated with any of the persisted object types in the Force.com database. For example, invoice statement C. So in this example, invoice statement C custom object, this here, is being instantiated and put into the sObject S. And since sObject is a generic abstract type, this is allowed. Now another example of sObjects would be something like this. So within our Apex code, we're declaring an invoice statement C, a custom invoice statement called INV, and we're instantiating it with a description and a status. And now, this is the real power of sObjects. You can declare and instantiate them just like any other Apex variable or class, and they tie directly into the database backend. Now, this next piece of example code is just an illustration of how you could cast some other sObject variable into an invoice statement custom object. So this is all just kind of general usage of sObjects. Another example would be to use dot notation like you do with Apex classes. So you could say, rather than assign the description value when you instantiate this sObject, you could do it using dot notation, just like any other Apex object. In addition to setting fields, you could also use it to read fields, like in this example. So you could read the ID and the name strings right out of this sObject as if it were any other Apex object. So that's kind of some general usage for sObjects. We're going to go ahead and try this. Now in this example, we're going to create a new invoice statement. We're going to set the description, and then we're going to print that description out to the debug log. So let's go ahead and give this a try. Okay, so we got what we expected. Now that's basic usage of sObjects, but beyond using them as simple variables or objects within Apex, you can also use them along with SOQL and SOSL query language. Salesforce Object Query Language, or SOQL, is a query-only language. While similar to SQL in some ways, it's an object query language that uses relationships, not joins, for a more intuitive navigation of data. This is the main query language used for data retrieval of a single Salesforce object and its related sObjects. The other query language, SOSL, or Salesforce Object Search Language, is a simple language to search across all multiple persisted objects simultaneously, and it's similar to Apache Lucene. Now we're going to do some examples of the different kinds of queries in the next exercise. So go back up to Debug, Open Execute Anonymous window, and now we're going to do a couple SOQL examples. So in this example, we're declaring an sObject and assigning this SOQL statement to it. And what this SOQL statement will do is it will select the ID and name from the merchandise custom object table where the name is pencils. So we're going to get the ID and name from the custom merchandise table where the name is equal to pencils. So if you're familiar with SQL, you'll notice that this statement looks very similar to a simple SQL select statement. Now I'm going to show you another example of a simple select statement. This statement would ultimately get the same thing. We're still looking for the pencils record from the merchandise table. In this example, we're doing a few things differently. We're still performing almost the exact same select statement, except rather than having the string here in the where part of the statement, we're using the myname variable where myname is equal to pencils. And you can include variables in SOQL statements, but you have to precede them with a colon. That's the explanation of the statement. Now, rather than assigning it to a simple sObject, we're assigning it to a list of merchandise objects. So this is useful because in the event we got multiple results from our query, we would get them all in a list rather than just the first available result. Now we're going to do another example. So what this is going to do, this is going to get the total inventory of pencil objects in our merchandise table and print it to the debug log. And you can see that by the SOQL statement here, which is similar to what we've been doing, but rather than get the ID and name, we're getting the total inventory field. So select the total inventory field from the merchandise table of objects where the name is equal to pencils. And so we're doing that, and then we're getting the first result because we're only expecting one. That's what this, so we're getting the first result in the list and referencing the total inventory field. So all that there will get us the total inventory. We're casting it as a double and putting it in the total inventory variable in our Apex code, and then we're going to write it to the debug log. So we're going to go ahead and execute that and see what that looks like. We should get a pretty high number, I think 1,000. Go ahead and run that and we'll see what our result is. And that's correct. So we have 1,000 pencils in our merchandise table. Now that's an example of SOQL query language. Now we're going to take a look at SOSL, the Salesforce search language. So SOSL queries evaluate to a list of lists of sObjects, where each list contains the search result for a particular sObject type. So in this example, we're searching for pencil. So anything that starts pencil and then any suffix on there. So we're going to look for that string in all fields that return a merchandise custom object or an invoice statement custom object. And we're going to do that search query to search list, and then merlist and invlist is going to take the list of merchandise objects from the result, and then the list of invoice statement object results from search list, and put those into their own objects, and then it's going to print that out. So basically what this is doing is it's searching the entire Force.com database for any objects named pencil in merchandise or invoice statement. So it's going to find any merchandise entries or invoice statement entries for pencils in my database. Now I should see one merchandise entry because they're in my inventory, and I shouldn't see any invoice statements because I don't have any invoice statement entries for pencils. So if I run this, we've got one merchandise item and 0 invoice statements. So that's a really basic example of SOSL, and it's really powerful when you need to kind of comb through the Force.com database. So we've looked at sObjects generally and how you can use them in Apex and how you can kind of treat them as any other Apex objects, except they have a special naming convention. And now we've also looked at the query languages you can use with sObjects and how to make queries against the Force.com database. Now, next we're going to talk about relationships. Since sObjects represent items in the force.com database, naturally they're going to have relationships to other objects in the database. You can evaluate those relationships a few different ways. One is using dot notation. So I'm going to go ahead and open the execution window again and show you a few examples. So this is a very basic example of dot notation and relationships with sObjects. So let's say you have an object, object A, and you want to get a parent object from it. Well, all you need to do is object A dot the name of the relationship, then you'll receive the parent object related to object A. So I know it seems a little abstract. In a moment we're going to do an example to kind of show you how this would work. So you can also get data from parent or related objects using the same kind of notation. So if there was an object related to object A, you could reference the relationship using dot notation and then immediately reference the field that you want and pull that data right out into a variable. Now, this notation works really well with parent objects since there's typically only one parent object. Now, if you wanted to get child relationships to a given object, you could say, you could reference the object and use the name of the relationship that the children objects have and put that directly into a list of the sObject type of the children, and then you would have a list of all the children of object A. So that kind of shows how dot notation would work when you want to find related objects to an object you're working with. You could also use query language to get them as well. Do something like this. You could select using the relationship name and a field. So let's say you're going to get the name of some parent object type from the sObject name of your primary object you're working with, and then set some where condition. This would be another way to get related objects. And if you wanted to get child objects, you could do something like this. Now this would be an example of a nested query that would let you get all the child objects of sObject name given certain conditions. Now these are general examples of how dot notation and querying would work when you're trying to explore related objects. I'm going to give you a real example right now just to kind of let you see what that would look like. So in this example, we have a line item. So this line item called li is going to be populated by this query. Now, what this query does is it's selecting the name of a related invoice statement from the line item table or object, depending on how you want to think of this. And we're going to get just one. So we're querying the table of line items for one result, and we're getting the name of the related invoice statement for that given line item. So this is an example of how you can reference related objects in queries by using this kind of notation. Now, when we write it to the debug log, this is how you would show related objects using dot notation. So we're going to write invoice statement name, and then we're going to say li, which would be the line item, and we'll say dot invoice statement relationship. So we have this R at the end rather than a C. C denotes custom object, R denotes relationship, so invoice statement relationship dot name. So we're going to get the name of the invoice statement related to li, our line item. Now we're going to execute that. And that gives us invoice statement name INV0000. So I'm going to show you where this came from. This actually came from a custom object in my force.com database. So if I jump back over to here, here's my line item 1, and it's the only line item in the database, so it's going to be the only one that was grabbed by that query. And we've got the related invoice statement is INV0000. So back to our code, we're selecting one item from the line item table, and the data we're interested in is the invoice statement name. Since there's only one, we're going to get that single record and we're going to print it to the debug log. So that's an example of how you can use query and dot notation to get parent objects. Now we're going to do an example of child objects, which works a little bit differently. So in this example, we're using a nested query to get all of the child objects of a given invoice statement. So I'm going to go through this right here. We're declaring an invoice statement, INV, and then we're going to use this compound select statement. So first, we're going to select the ID, name, and some other information. I'm going to do that from the invoice statement table where name equals INV 0000. So we're concerned with that same invoice that we just looked at. So INV 0000, which is the only one in the database. So we're selecting that, but also within this select statement, we're selecting ID, name. We're also selecting units sold from the line items related to this invoice statement. So not only are we getting the information from the invoice statement, we're doing another select on the related items for that given invoice statement. And then what that allows us to do is to create a list of line item objects based on the line items related to our invoice result. And if we do that, we should be able to see, in this example, it's going to tell us how many line items are related, which should only be one. Let's go ahead and run that. You should see one, which is correct. And now, just to reiterate this, so we're doing two things here. We're getting ourselves an invoice with this name, which is pretty basic, but then nested in this statement, we're asking it to also look up the related line items with respect to their units sold. And then since we do that statement like that, it allows us to pull out a list of all the child line items. And then so we've got our INV sObject that represents our invoice. And then we've got our LIS sObject, which represents a list of all the line items that are children of this given INV. So, and I could even take it one step further and say, so if I go ahead and run this again, it's going to tell me how many line items I have that are children of my invoice, which we know is one. And then I went one step further and I told it to also print out the units sold for that one line item that it found as a child. So let's go ahead and run this. And we've got number of units sold 5. So if we go back to our line item we were looking at from the previous example, units sold 5. So it managed to look that line item up correctly, and as expected, units sold 5, and it's related to our invoice, INV 0000. So there are a couple different examples of how you can access related objects in Apex using both the dot notation and queries of the Force.com database. So far, we've talked about the basics of sObjects and queries, and we've showed how to traverse and query sObjects for relationships. The next thing I want to talk about is using for loops with SOQL queries to iterate over database results. This is actually really simple, and you can see that in this example. So using a for loop alongside an SOQL statement will allow you to perform actions on, in this example, every single merchandise record. So I said for, and then I declared some temporary object. In this case, it's a merchandise object with the name TMP for temp. And then I list my query. So in this case, you select ID from the merchandise table. So that'll query for all the merchandise, and then using TMP as a reference object, we can perform operations on every single merchandise object in the database. Now, this will work, but the more correct way to do this would be to declare TMP as a list. And the reason for this is it's more efficient allows this list variable to hold the batch of records returned by each iteration of the loop, and this allows for bulk processing of database operations. And in doing this, you'll be less likely to have problems running in your Salesforce sandbox. Salesforce is a very strict environment, and you can hit execution limits and have problems with performance if you don't use best practices when writing your Apex code. So this would be the best way to perform this for loop operation on all merchandise in the database. So that's a quick little example of using for loops with SOQL statements. So in this lesson, we've covered sObjects, how to query them with SOSL and SOQL queries, and how to traverse their relationships. But now we're going to move on to actually manipulating those sObjects within the database using Apex Data Manipulation Language, or DML. DML enables you to insert, update, delete, or restore data in the database. I'm going to start with a very simple example of DML. All right. So in this example, we're creating a new invoice statement sObject called INV, and we're going to initialize it with a new invoice statement, and its description will be my new invoice. Now we're going to use the DML statement insert to insert this new sObject into the database. So I'm going to go ahead and execute this. And now we've inserted that record into the database. Now we can see the changes we've made if I jump over back into Salesforce, and now we've got two invoices where we only had one, my new invoice. So there we go. Now we've actually made changes to our Force.com database using Apex and sObjects. So I'm going to go back to the developer console. And now that was an example of using an insert statement. Now I'm going to update an existing database record using DML. Actually going to update the same one we just created. So now we're going to create a new invoice object, and we're going to use some SOQL to select our invoice we just created, and I'm going to update the status field to negotiating, and then I'm going to call the DML command update to update that object in the database. So let's go look. Status is open currently. Now if I go and run that code, we should see that change. Okay, so that ran. I'm going to refresh this page. And now the status is negotiating, just as we expect. So that's how to update records using DML. Next example is I'm going to delete that same record. So I'm going to use the same SOQL statement to select that record from the database, and then I'm going to delete it using DML. So let's run that. I'm going to jump back over to Force.com, and when I refresh this, the record's been deleted. Now you'll notice that this statement says right here that we have 15 days to recover it from the recycle bin. So that's going to be the last example for this DML demonstration. So I'll go back here. And in this last example, we're going to select the record again using SOQL, but this time we're going to add all rows at the end. The reason we needed to add the all rows modifier at the end of this SOQL statement is so that the system is able to locate this deleted record. But this should be able to find our data for us, and then we're going to use the DML command undelete to bring it back. Let's try that. Now that that's done, I'm going to go ahead and jump back into Salesforce. And now if I refresh this, we've got our invoice back. So that's one way to use DML, by using the insert, update, delete, and undelete reserved words in Apex. Now, there's another way to use DML, and that's by using the database DML methods. I'm going to show those examples next. So the database DML methods are methods associated with the database class in Apex. In using the database methods instead of the DML reserve words, you get a little bit more functionality this way. One of the benefits is you get to save the result of a database operation into a class and process it later. Another advantage is there's a flag that can be set that allows you to indicate whether a DML command can have partial success. So, for example, if you run a certain statement and part of it fails, but not the entire statement fails, then you can set a flag that would immediately end that operation or that would allow it to proceed and complete even though there were problems. So here's our first example of database DML methods. And here's what's going on in this example is we're creating two new invoices. One, my new invoice, and another one is another invoice. We're going to insert both invoices into the database using database methods. So, and you see that here, we're calling database.insert, and we're creating a new list of invoice statements, and we're populating that list with INV1 and INV2, and we're setting the partial success flag to false. So that's going to go ahead and run that insert and save the result. And then here's one of the advantages of the database DML methods is we can run this for loop down here that will iterate over the saved results. And if anything is not success, it's going to give us an error. And then we'll be able to take these errors that we processed and report on them or take further action. So I'm going to go ahead and execute this. All right, and now we should see our two new invoices over in Salesforce. There we go. Got 2 and 3. We've got my new invoice and another invoice. Okay, great. So let's jump back to the developer console. So now that we've used our database DML methods to insert some records, let's go ahead and delete them. So we're going to run this SOQL statement that's going to get us both invoices we just created by description and put them in this list called INVS. And then we're going to do database.delete on our list of invoices, and we're going to save the result to DRL. And since I don't expect to get any errors, there's a loop doing error checking, but that should come up without any errors in this case. So we're going to go ahead and run this, and that should go ahead and delete our two new invoices. Oh, and you know what? Actually, I forgot. The description of our first test invoice was also deleted because the description was the same, and I hadn't considered that. But that just goes to show the power of SOQL. So we're going to move on to our next example and bring those records back. Let's jump back over to the developer console. And now again, we're going to do another SOQL statement, grabbing our invoices by description. We're going to add the all rows modifier to make sure we get the deleted records. I'm going to put all those into INVS, and then we're going to call database.undelete, pass our list of invoices, and then we're going to collect the result in undelres. So I'm going to go ahead and run that now. That should bring back all 3 of our new test invoices. And there you go. So that's going to wrap up our examples of DML and database method usage. Now, in general, you're going to want to use database methods instead of DML statements if you want to allow for partial success of bulk DML operations. But for simple statements, using DML will work just fine. Now, the other case to consider is if you use database methods, you'll be able to take the errors from any DML operations and process them within your Apex code. Unlike DML statements that if any errors come up in those processing, they'll be thrown as Apex exceptions and immediately interrupt the control flow. However, you can handle that in exception handling, which we will go over in the next lesson. So that's going to kind of wrap up our introduction to DML and database methods. And so that concludes our lesson on sObjects in the database. In our next video, we'll cover Chapter 2, Tutorial 9, Exception Handling. Thank you for joining us. For more great content, click to subscribe to us on YouTube. Thank you.